Hello and welcome to this Consulting Specifying Engineer video discussion. I'm Amara Raskus, and today I'm speaking with James Abney from RenewAire. Hey,
Hi.
James.
Hi.
Good to see you.
Good to see you too.
Awesome. So we are at the AHR Expo in Orlando, where the focus is on HVAC, building automation, and controls. We're on the trade show floor, and I am happy to talk with James about energy recovery ventilators. So first, let me give you a little bit of background. James Abney is the Technical Sales Support Manager at RenewAire. He's based in Waunakee, Wisconsin.
Yes.
All right, I knew I was going to get that wrong. He has worked in product development, application engineering, product management, and now in leading overall support for the RenewAire customer base. So a lot of questions here, James.
Yeah.
Start with some of the basics.
No worries.
There's a push toward decarbonization. How are ERVs being integrated into all-electric HVAC designs? And what are some of the challenges in a humid environment like Orlando?
Right. So decarbonization is tricky because we want to save energy, we want to save the planet, but simultaneously we need to keep people healthy, right? So as buildings get tighter and tighter, you're trapping all the contaminants inside the building. So you have to provide fresh air. Sorry, there's traffic around us. You have to provide fresh air, but then that's very expensive to condition, obviously. So that's why we include the plate heat exchanger to save energy and to transfer both sensible and latent energy from the exhaust air into the incoming airstream. So in the summer, we're rejecting the heat and humidity, and in the winter, we're warming the incoming air as well. So challenge-wise, let's say in Florida, we're in Orlando right now. It's very humid outside, and yet you have to still ventilate somehow. People need fresh air, whether we're in the Midwest or you're in the Southeast, right? We want to keep people healthy. So you're going to have to reject both the sensible and the latent energy regardless. And so that is why you use a plate heat exchanger to do that. Ultimately, there are extreme cases though, and so you're going to need some kind of post-conditioning. But imagine if you didn't have that plate heat exchanger, then you would just be covering the entire load with whatever cooling device you have, such as a DX coil, chilled water, or whatever. You would do the entire load. So at least with our plate heat exchanger, you're rejecting some of it initially and then cooling the final bit afterwards, or rejecting the moisture afterwards. So that's the idea, basically.
Okay. So let's get a little bit more specific. How does the static plate enthalpy core in the HEO5 compare in efficiency and effectiveness to other heat exchange technologies? And, we're looking at rotary wheels, counterflow, how does it all work?
Right. Yeah, and so as an engineer or an end user, you have various options, really. So there's wheels, which are very effective but have downsides, which I'll talk about in a second. Counterflow is a very interesting technology, but it doesn't scale very well. So you're topped out around 200, 250 CFM, which is very almost residential. You can't use that on a large space. So a plate heat exchanger gives you the best of both worlds because it's very effective, but it just sits there. It doesn't move. Whereas a wheel, you've got a spinning disc of metal that's coated with a desiccant. So you have belts, you have motors, you have VFDs, you've got controls, and seals. So you have a lot of potential failure points. Versus with a RenewAire product, with our plate heat exchanger, it literally sits there. And so, maintenance people might not always be on the top of their game. They might just leave the unit for years, never open the door. And so if you got a wheel or something like that, you got a problem. Because what if the belt breaks? Then, as I talked about before, then you're just bringing all of that unconditioned air from outside straight into your building. And effectively, you don't have a heat exchanger at that point. Versus with a RenewAire plate heat exchanger, it's always on. If air is moving, our product is working. So that's why it's the best of both worlds, and that's why engineers use us, is because we're very reliable technology. So again, shifting to counterflow, that's more of a HRV space at low CFMs. So it's a very limited application, I would say. Interesting technology, but again, very limited.
Okay. So speaking of advantages and integration and all that stuff, how do you integrate the HEO5 into a centralized HVAC system? And this is versus operating in a standalone system. Like what's going on there?
Yeah, so really you have two options. You can duct the unit, like have its own separate duct. The problem there is an ERV isn't meant to fully condition the air. It's to remove the initial bit of load, right? So let's say 0 degrees outside, 70 inside, we're going to warm the air up to about 50. However, that sounds great and is amazing, but in the winter, you don't want to dump 50-degree air on people's heads, right? And that's why you typically are integrating into a larger system. So say a homeowner or something like that, they've already got their furnace duct, so you just tap into that, right? And so you don't have to do all this extra duct work. Plus you get the advantages of cooling and heating your ventilation. So ultimately it makes sense to integrate unless you can supply to some general space where people aren't feeling it until it's mixed in. But overall, we want to integrate into a central air handling system.
Okay. Well, thank you for that terrific overview, James. It's great to connect with you today.
Yeah, nice to meet you as well.
Yeah. So for more information about ERVs and other HVAC systems, visit Consulting Specifying Engineer at www.cscmag.com. Thank you so much, and we'll see you next time. Bye-bye.